Okay, for people joining this meeting, this is a kind of early exploratory meeting in the project of figuring out how to integrate System Modeler with things like our entity framework. So maybe we should start off with a bit of a reminder about System Modeler and its integration right now into the system. So let's start off with System Model examples, which is a prototype example of a repository browser, basically. At least that's the way I view it. And I think, let's see, Jan is here, right? So you should be speaking up about what's going on here, right? So right now, Jan, are you here? Hello,
sorry,
Jan.
Sorry, I had a problem unmuting.
Okay.
Yes, so System Model examples, it's a browser of the packages containing examples and components that can be used in System Modeler.
Okay, so let me understand, relative to what all is available in System Modeler. I mean, if I go to the System Modeler homepage, will I find a different set of
if you go to the System Modeler application, you will see a more complete with this. This is focused on the examples, things that you can run and simulate directly.
So if I go to the website, where would I go to find this stuff?
You don't find it on the website.
Okay. So if I actually start up System Modeler, you're saying?
Yeah.
I hope I have the most recent version.
Or recent enough. It's
okay.
Doesn't matter. So basically, it's on the left-hand side here. You see the class browser. That one contains all the examples you find, but also other things like components that you can use to create other examples.
Let's just understand. So, I mean, my question is this: we have a pretty good pattern now for for the function repository, other kinds of repositories. The question is, first question is this a fit for that? Okay.
There's not a one-to-one match. That's for sure.
No, I understand that. I understand that. But I mean, to me, there are two primary. Here, let me just save this.
So I think that we don't have anything in our system that's primarily sort of building blocks. This is like, think of Lego, okay? So they're kind of, you can get a ready-made kit, build this, it's exactly the pieces you need to build that. Or you can get general purpose Lego pieces of various kinds. Okay, so if you open a class browser there again,
I will in just a second. I'm just curious what from 2019 we had some notes here. Okay, so this was horrible garbage, I'm afraid. I'm sorry to say, this was really shocking. What was done there?
Well, Malte should be here, with in that case, if we want to discuss.
Well, yeah,
that.
obviously we need to have him here. Yeah, obviously, if he's the one.
But I thought this was the future of it, and I was going to set this up, but with the appropriate sort of Trottian complement, so we could work through this.
Okay, well, fine, but I don't know. Then this meeting got scheduled anyway. But so we're here. So
you drove this. You're driving.
I don't know what happened with this. I don't have an assistant right now.
I had sent a request because Stephen, you had originally said you wanted to have proper, pure, non-entity Wolfram language representation of some things like electric circuits.
Okay.
Which is yet another branch.
Okay, let's write down the branches that we're dealing with. Okay. Directions here. Okay, one is repository eyes. Classes,
so we have a repository. We call it the library store for System Modeler.
Fine, we're going to look at that in just a second. Okay, repository eyes things. Okay, repository. Okay, that's one thing. The other thing is the entity. You know, entityizing, repositoryizing, entityizing. Okay, and the third thing is systemizing. Okay, that means actually making a built-in, just like, I mean, you know, we've been very successful now in chemistry, having actual built-in, you know, structures for things in chemistry and so on, right? So the question is, should we be doing that for things like electric circuits and other things which are, you know, very generic, very kind of widely used, you know, concepts which also exist in System Modeler, right? And maybe that was what this meeting was supposed to be about, but it was mistitled, so I didn't know. Is that what this was supposed to be about, Michael?
This is what you said you wanted to have a meeting about. That's all what I can comment.
Okay. All right. Well, let's talk about that for a minute. Okay.
Should I be getting Malta?
If you can, yeah.
Okay.
But I want to see how this works first, and then maybe that will help. Okay. So let's say I want to know about electric circuits. Where do I go?
So first of all, open Modelica. Okay. So I was just going to explain the sort of the Lego kit analog of what this is. Okay. So here is like an analog kit. So if you want to build models that are analog electrical models, then these are the building blocks that you will, you know, need or want to do that. With these building blocks, you can drag and drop and connect to build actually models.
Okay.
You know, you have to, well, don't do that. Then you drag and then you.
Oh, there, like that.
Yeah.
Okay.
Right.
What happens if I want to twist this around to make it go down?
You have to put you click on the, did you see the connector up there in the top bar? Go up, there, left, that one.
I see, okay.
And that one you need to use all the time to connect things.
So you didn't actually connect.
Yeah.
You need to put that, but no, well, why would you do that?
So I move those apart,
Yeah,
and then I use the connector
Yes.
to connect from here to there.
Right.
correct.
Okay.
Now, these wires, they look like a single wire, but sometimes they're complicated things. Like you have vector wires, you know, they transmit the physics between them. So in the case of a circuit, they deal with current and voltage.
Yep.
You know, if it was hydraulics, it would be pressure and flow, for instance. So what we ship with is a ready-made set of libraries. If you look here, if you browse, if you kind of close up, we can see what those.
It's just weird that this is different. It's just weird. Okay. All right. Go ahead.
No, so even under electrical, you can see that there are actually sub-kits there, okay? So digital electronics is different than analog electronics.
I realize, right. I was just looking at basic.
Yeah. And one thing that you see there is that there is a set of examples, okay? There are not that many, but you can see under each such kit, there is a set of examples that actually do use them. But these are basically, yeah. And they make use of those components in that kit.
But so these examples are not on the web, is that true?
Well, there are on the web in the sense that we built web documentation and.
No, but I mean, but wait a minute. If I want to see adder 4, can I see that on the web or not?
Yeah.
Okay, where is it? So if I go here,
you could. Yeah, the easiest is probably search. Yeah, it should be under reference.wolfram.com where we have it. So if our search worked, it would have found it.
Please report the failure of the search thing.
Okay.
Bye.
But if you, there's
that's not the right thing.
Oh,
no, that's
sorry.
another thing.
That's not the right thing.
Sorry.
This isn't the right thing.
Ignore me then.
Can somebody find me the actual URL for adder 4, please? This is pathetic. I don't think this is being searched. I think you made a mistake here. I don't think this is being searched. Either that or it isn't true that these things are on the web.
Well, there is a system modeler section. It doesn't look like it's being searched.
Are you serious?
There's a spell correct notification there.
No, that's not. The other one wasn't. Okay, so this looks like kind of old, a bit old, right? But it is here.
It is here. So it will be refreshed and regenerated as we build the documentation for the 13.0 release.
Is this click to copy?
No, I think that's
Yeah, yes, to watch it.
the example below is click to copy. The
Except
command.
that's blue for some bizarre reason. Okay. All right. So.
And now in the new version, when you do system modeler, there will be a link to this collection of documentation.
What do you mean in a raft here?
No, if you go to the page, the system model page.
No, I understand, but are you?
So it's like import doesn't have.
No, but what we need to make sure of is that we're actually using the whole raft mechanism right here. So does this? Hold on. Okay, so that is some kind of ranked list here, correct?
That looks very weird.
Yeah.
So that's wrong. So get it right. Okay, so that's another thing for your list. Who here is making the list?
I don't know who's making the list, but I'm making notes.
That's fine. If we get the notes, we can. So that's just wrong. What's that?
Yeah. Okay. So that T user assistance. That's the that's the right place. Okay. So that's that. Okay. So now.
No, but if you look at the source to the system model, okay, we don't have 13.0 built documentation yet, right?
No, I get it. Yeah. But I'm just commenting on what should happen here. So, I mean, in a perfect world, just like we have, when you say RGB color, and
there's nothing there.
Why is there nothing there? Oh no, I know what the problem is. Choose color. See that?
Mm-hmm.
That is essentially a, that's an enhanced autocomplete. And what we want to work towards is having something like that that is essentially a repository browser.
Mm-hmm.
You get what I'm saying?
Makes sense.
Okay. So what that relies on is being able to take this, what you've got here is our only example right now of a repository browser. I don't particularly like this one, but we don't have any other repository browsers, right? We intend to have a function repository browser. Do you see what I'm saying?
Yeah.
And we should then standardize how the repository browser works. But one of the things which I wanted to address for just a couple of minutes here before we turn we're going to return to all these different pieces, okay? So first question is, does it make any sense to have resource objects associated with each of your items here? Do you see what I'm saying? In this, right?
Mm-hmm.
We could have it be the case that every one of these, a U-line, whatever a U-line is, what did that do? When I double click that, is that bringing me up a U-line as my only?
Yeah.
Yeah. So it's open up that particular.
Look at all the tabs
object
up
class.
there.
Yeah.
Look at all the tabs up there.
I see. Okay, fine. Okay, and so this has many parameters, correct?
Mm-hmm.
Mm-hmm.
Right. Okay. Gosh, I hate the fact that we haven't been able to get proper integration for this stuff. I really hate it. Look at this thing. Well, whatever. I mean, I could, this is a very nice interface. Very nice interface. Just a shame that we have such incompatibility. And maybe there's nothing to do about it. Maybe it's hopeless.
We've decided to not build deep compatibility. That would consume. So it leverages. We have founded and we are part of a community developing a language called Modelica for this. Right?
Yeah.
And so we didn't develop another language that's incompatible with all that. But what we do have is a way to not sort of in the Wolfram language. I
have no idea what any of this is. I mean, as far as
this is Modelica. This is Modelica.
Garbage. Yeah. Right. I mean, this is just like a completely separate thing.
Mm-hmm. But in terms of usability, so you can programmatically build, you can interactively build this model using this product, right? You can programmatically build them using the Wolfram language. You can do analysis and design work in the Wolfram language, because this primarily, if you use this product as is, it's primarily meant to be a modeling framework.
What if I have a piece of Wolfram language code and I want it to run inside?
When you can't. No. So that's not possible, but that's a future extension. But the Wolfram language code, usually we need to sort of segment it out, because Wolfram language code is usually pretty slow compared to the simulation code, Well,
but that won't be true with compiled code.
Well, I mean, it's different things. You can build, it's okay that some things are slow. Like if you run an imaging loop, let's say that you build a cyber.
Yeah, I understand that. But I'm okay. Saying if I want to actually build something, okay, so look, what we have to decide, maybe we decide we're just not going to try and integrate these things, right? But, what I think we need, okay, what was, I guess, the original purpose of this meeting is the possibility that we should build into our language, the capability to do things like electric circuits. By the time we're building elaborate, heat transfer PDE stuff, why are we not building basic ODE models? Now, clearly, System Modeler has much more sophisticated ODE models, but the question is, should we have something where we have a function called resistor, or resistor model or something like this, where we literally have something just like we have for PDEs, we have this elaborate system for representing PDE modeling. Why are we not doing that for these basic things like this?
Yeah. It's
we're clearly not the problem is we've already got deep coverage with gyrators and whatever CCV.
We do have deep, yeah.
Right. We have deep coverage. We're not gonna. It makes no sense. We're not going to repeat that coverage, right?
Mm-hmm.
But it also doesn't make sense that if I just want to put together a simple RLC circuit as sort of a proxy for, I don't know, some model of a tree or something, right? That I'm going into this, diving into this weird other language and doing all those kinds of things. Right? It doesn't make any sense. Just like it wouldn't make sense if suddenly when we were going to use, I don't know, sparse arrays, we suddenly have to dive into some completely different world with 75 options for everything. Right. The question is there a piece of this that is, like basic electric circuits, basic mechanics, that is sufficiently generic?
But then you're talking about, so Jan sent something out there, you can connect components, but it's still a bit weird. It's kind of a, if you click on what Jan sent out in chat, it's so you can still do it. Okay. But I find that it's a bit, look at that.
Well, so let's make an electric circuit.
Mm-hmm.
Yes, this is grotesque. This is utterly grotesque.
Right.
It's got dots for, and underscores and all kinds of things. It's completely incompatible concepts.
Right. But then what you're talking about is us basically designing our own base language in place of Modelica.
Yes, that's correct. That is correct. I'm talking about either that or potentially making a wrapper around this that turns it into something. But again, we don't need, and I'm not sure how to set this up, but the depth of coverage here is important for engineering, irrelevant for generic modeling. Am I making sense? In other words,
what is generic modeling? Just
I mean, somebody who is, I don't know, they're making a model of some feature of a pandemic, and they want to use the analogy of an RLC circuit, okay? And they want something which essentially is going to give them, just like in, in the PDE modeling world, I don't know whether the fact that we have acoustic PDE models, right? Presumably those will be used by people doing acoustics. I'm not sure. I don't think it will be horrifying for somebody to say, I'm going to use the acoustics model to model some feature of perturbations in the early universe, even though there wasn't anybody with an ear in the early universe, if you get what I'm saying. But it happens to be the same equations.
Yeah.
Making sense?
So in a sense, there are two additional libraries here that do sort of that. System dynamics library, where you have an abstraction where, if you look at the here, the capacitor, for instance, that's just something, sort of a storage, a volume or something. It could be representing different things. So there are things where you have that more generic representation, where you're not saying that this is a capacitor, you just say this is something that stores something.
Right, but I mean, so to me, the difference is you might have a capacitor there that is a such and such, SKU capacitor from such and such vendor with these characteristics. And that's what this product is about capturing.
I think that there is about, I can't remember now, but I think it's on the order of between 5,000 and 7,000 objects to introduce.
Yeah, right.
With this,
which we don't want, right? Which we don't want, right? That's the whole point. What I'm saying is, if you included every item in, I forget the, in these big catalogs, of components.
But these are not. So the other thing that you're talking about, which is one level up from this, like an electrical motor, that's something that's built from a bunch of this, from several of these kits, basically.
I know.
Okay.
I know.
And there's a whole world of those.
I'm well aware of that.
And this is not intended to be like a catalog of electrical motors. To I'm saying.
Although in principle, somebody could have a Modelica specification of those things, which they could feed into the system.
Yeah. And actually, it's useful for other reasons to want to have such a thing. Like if you buy a product, can I also get a model of it?
Sure. Right. No, it's obviously.
So, and maybe a way to sell a product is to give you the simulation model so you can play with it and design it in.
I understand. That all makes sense, right? And that's why, lots of companies that sell components have
CAD
somewhat
models.
computable, CAD models, somewhat computable spec sheets, et cetera, et cetera, et cetera. All makes sense. Okay. So one question that exists here is, there is a level of engineering detail that you have here. That level of engineering detail is utterly irrelevant to the person who's learning about RLC circuits. It's utterly irrelevant to the person who is using an RLC circuit as an analog for, something about some random, piece of epidemiology. Am I making sense? They don't care what the breakdown voltage is for that capacitor, for a CJ75 capacitor or something, right? But the engineer who's designing the system modeler does care about that. So the question is there a level of idealization that we can, because the thing that doesn't make sense to me is that we have things like detailed acoustic PDE models and we don't have RLC circuits. Do you get what I'm saying?
I tend to agree with you. But I don't think that has to do with entities, though.
It may not. It may not. Look. Okay. Let me again. I'm just trying to put pieces together here.
Yeah.
So system modeler is a deep engineering level coverage of things.
True, but we are also building shallow learning versions of it, like our.
Well, great. But then the question is, could those be could we take what is being done there and simply transport it into Wolfram language? And if so, what is the correct transport mechanism? Because it isn't things with little dots in them.
I agree with you. I completely agree with that. But why don't?
But it's not. It's easy to agree with. It's harder to find the solution.
No, we'll have to actually work on it.
Yeah, one has to do work. But that's why what I want to survey is what are the frameworks that we have in the language and in System Modeler that might connect. Okay. That was what I was. That was kind of what I was looking for here. And so I think there are these.
So if you want to think about sort of what we modeled, what we provide in the Wolfram language interface now is basically that connectivity interface. So you can see a component out there. It has various ports. Those are those blue squares here. They're ports.
Yep.
So what can connect to what?
Yeah,
and in the language, in the string,
this one here. Could I take this particular one?
Yeah.
This is how do I copy the name of this?
Uline? I think you can just copy it and paste it into Wolfram language.
Okay.
Yeah, just paste it. Paste.
Okay, all right. So I just say system model. What
well,
do
you
I
can't
do? I just say system model and then I paste that name. Is that correct?
Well, you could do that, but you could also have just pasted it. I think it would have just worked.
Yeah, but it just pastes. No, that just copies the string. So this was the right thing to do. And now that just shows the diagram of it. And
okay, so now how do I get all this stuff here? How do I get this information here?
That's asking for the properties that it has.
Yeah, right. So how do I do that?
System model and let's.
What the heck? Why did that not work? What the heck is this?
What build are you in?
I don't know. Some build that isn't working very well.
Clearly, yeah.
Let me just quit this and I'm going to restart with a different build. I think this build is all of 2 days old.
So go to that homepage, okay? So then system model that, and then you can ask for properties.
Okay, let's go there. Hold on 1 second. I mean, I would like to make a meta comment here. I am pretty sure that with a bit of cleverness, we can leverage the huge amount of work that's been done in System Modeler to make it really rather easy. It's going to be some framework building to make this bridge, but it isn't a rewrite everything story. Am I making sense?
Yeah.
Would it be possible to somehow convert automatically in the back end, convert some of this into a demonstration? If we have the code that would be generated on System Modeler, I don't know how that works exactly, but if we convert it to demonstration, then you can expose it in the entity framework. And I'm pasting into the chat something you could try now to sort of simulate a basic electrical circuit. We could just extend the coverage somehow.
So first of all, it works, in a demonstration right now, because
but but this is, what the heck is this? This is an actual demonstration, right?
Yes.
Wow, I wonder how this works. No idea how this works, but in any case, okay. But that's just making the point that the demonstrations project, which we haven't mentioned up here as part of our is a place where we have an entity-based representation of. Okay, so this is a demonstration as an entity. Does that make sense to you guys?
Oh, you decided to suck all the demonstrations in?
Yes.
Okay, fine. Well, I sucked them in as packlets once upon a time. So yeah, it's easy to do.
I understand, but the whole point, Roger, is we're trying to figure out how do we take what's here and make the right kinds of things exposed in the language. Okay, let me see.
Right. But you, okay, there's a thing that you have to understand, that a lot of components can't be simulated. A resistor can't be simulated
without connecting it to a lot of other stuff.
Yeah.
Yeah.
No, I understand that. I understand that. So I'm just like if you say, you know, can you solve the equation x squared? No, it's got to be x squared plus x equals something or other. That's an equation you can solve. The pure monomial x squared is just a disembodied creature sitting there.
Well, yeah.
Right? It's the same type of thing. So, okay, so here, if I say, so if I take this thing here and I say properties, wow, why is this taking so long? Shouldn't this just give a list of properties? Oh, it did. Okay.
Yeah, the first time it loads the whole system of machinery, so that's why it took time.
Okay. Probably didn't need to, because every single system model has the same properties, doesn't it?
Yes.
Okay, so then you have parameter names and parameter values.
Okay.
Okay.
I remember designing this, right? So parameter
name, for instance, yeah.
Okay, which are quite grotesque.
Yes.
But those are the Modelica names, just like
yes.
Okay, let's give an analogy here. Okay, let's give an analogy. In the entity world, we have plenty of grotesque. Okay, so what do we do in the entity world for this stuff? Okay, so Michael or somebody, can you give an example of something where the actual name of an entity is somewhat grotesque? Let's try
people data.
Okay, let's try Alan Turing. Okay,
Right.
there he is as an entity. But what actually is that? Okay, well, it's got a bunch of crud in it there. You see what I'm saying? Because we need that for disambiguation, blah, blah, blah. So as an entity name, the stuff you have here is absolutely hunky-dory. There's no problem with it as an entity name.
What's an entity name?
I mean, what is it?
This the standard name, how the thing is programmatically referred to, not what you look at.
I see.
Like
Right,
the
so-
Alan Turing.
So this is for you guys in the entity world. You think of these things all the time, like an entity name.
Yes, that's right. So these things,
So this is like a key, like in a database.
No, not really. Like a summary box is a continuation of this. Summary box looks totally different than what's inside.
right, but the point for Roger's purposes is, what I'm saying is the names you have here, you don't have to touch, you don't have to do anything with these names. They're fine as entity standard names. Do you see what I'm saying? So, I mean, now the next question is, does it have, so now, does this have a human readable name? What is the, is there a parameter description somewhere here? Because there is over here, there's a parameter description, right? Is there not, or what is there?
Yeah.
What is that? Where
Yes,
is that, Jan? Where?
So on the
Where's the
list of parameters on the right hand, you have a description for each parameter. So each parameter has a value, it has a unit, it has a
right. So that
description.
would be, in our world, that would be the common name. Okay, this is the standard name. This Alan Turing is the standard name. Okay, it's the unique identifier, right? But if I say of a common name of line 5, or just let's put this thing in there, right? Common name of this, then I will simply get the string Alan Turing. Okay, and that common name is what's painted inside this yellow box. Does that make sense?
So how many keys are, I mean, that key, that Alan Turing 2F4S8, how many things does that look up? That's a key to everything.
From a couple million.
Yeah, I mean, there's millions of things that this is one of our entities of which there are many million.
Right, but what I meant is how many properties you call them, right?
Yeah. So we can ask for Alan Turing. We can say, what are the properties of Alan Turing?
Somewhere between 10 and 1,000, depending on the domain.
Right. So there's where the properties are. Now notice that these properties again are yellow boxes here. Now, if we take that object and we say, what is it, right? The input form of that is that, an entity property thing, which in that case is fairly human readable, but it might not be.
So those are not entities, there are entity properties.
That is correct.
So that's another thing that you have.
That is correct.
Do you have more things than entities and entity
There are a
properties?
few other things, yes, but those are the principal things.
So
So
the keys you call entity properties.
that is correct.
Okay.
We would have liked to call them properties if that hadn't been, stolen by the graph system at some point.
Well, if attributes hadn't been stolen for something completely useless.
Right. Okay. In any case, we are where we are.
And we have a similar system for Wikidata, we should say.
Yes, that's worth. Should we show a piece of that? Is that relevant? Because what I think is that there's a way to move this.
I'm still, Michael, I'm still going to want, if it's just about sort of getting this sort of entityized, then I still want to sort of have regular meetings, discussions. That's what I was planning to set up as soon as we're out of this release cycle.
Okay, well, fine, but I'm just going to I'm trying to make the general outline, because I think this is going to work very nicely. I think it's going to be rather easy, actually.
Well, it's well, okay, but you don't care.
What?
I actually think like the parameter names that you got out, where you say they are okay, but they are kind of not things I feel like at the level of entity. There are nearly more things at the level of, say, physical quantity variable. Yes, it also has a couple properties like dimensions and related things, but because they're all different, like everything that has kind of parameters like 1, 2, 3, 4 is frequently, I feel like, not an entity. It's something else, parameterized by some other domain. I'm
not quite sure I understand that.
Like a time series or a quantity series, something like this.
Like look at the result of the parameter names output that you have there, RC, length, N. I don't think they should become entities. That would be, I feel like, not.
No,
okay, good. Just make sure.
They should be something like entities, not probably entities themselves. And I don't know. I mean, Michael, when we do qualified entities, entity instances, what are the names of the qualifiers in entity instances? Let me. Okay, for Roger's, an entity instance is something like 3 grams of sodium or something.
Yeah.
Okay. So in this case here, well, here's a good example of an entity instance, right? That feels, I mean, I don't think these are very beautiful yet, but that feels very much like your qualified version, your parameterized version of your, whatever it is, uline object. Do you see what I'm saying, Roger and others?
Maybe, yeah.
Okay, this is saying a half torus is the general thing, and it has these parameter values. Again, I'm not totally thrilled with all aspects of how this works, but this would be, you have a uline entity and it has these parameter values. Because a half torus on its own is, we don't know, I mean, there are purposes for which it's useful to have the concept of the half torus entity independent of its specific parameter values. Do you get what I'm saying?
Mm-hmm.
And I can imagine that in the case of system
model. Part of what I've never gotten really is like, why would you want them as entities? I mean, why do all this? Why do you want them as entities?
So they fit into the rest of the system.
Why do they fit more when they're entities?
Because we have tons of functions that do things like entity classes, entity list, properties.
So you want the lookup functionality the searching functionality from the entity world to work. Is that what you,
among other things? Yes.
The main benefit you want?
But there are also things like where there aren't just 12 of them, where there are hundreds of thousands, like groups or something like this, where you can't either remember or easily programmatically build the names for things. Not.
Right. Where look. The point is,
my point. I'm challenging you a little bit. I'm not hostile or anything. I'm just challenging you. It's like, what do I get back if I make them entities? Do I get anything back?
Yes. What you're going to get
I
back.
just don't see
what
it.
you're going to get back is the fact that instead of all of us complaining every time we see this stuff in the system, we say that looks like garbage, right? All of this stuff looks kind of ugly, and it looks like it's some piece of object-oriented, something or other wheeled in, et cetera, et cetera, et cetera. We wouldn't be saying that.
I mean, Roger has a certain point. Like, what exactly entity versus other headers give is under discussion.
Yeah, that's under discussion. I agree. I'm saying an entity-like thing. I'm saying we learn from the entity framework what to do, because we've already worked this out for many aspects of, look, the two frameworks that I think are interesting to look at for this are the chemistry framework and the entity framework. Okay, maybe three: chemistry, entity, and PDE framework. Those are all three sort of pseudo models for what we're talking about here. Now,
I think also wiki is not uninteresting, Wikidata, and partially even if it's not so big, formula data. It's another big collection. It doesn't have its own header wrapped around, but it's something that has computational data.
Okay, all right. Well, yeah, let's look at that. Okay, so Wikidata, what's an example that we can show here? I mean, this is something which is very, this is a jungle. The Wikidata world is a jungle, but we are able to, we have good programmatic ways to interact with that jungle. Am I making sense?
Mm-hmm.
And so insofar as Modelica is a jungle, which I don't think it is nearly as much of a jungle, I think Modelica is much more similar in character to one of our either repositories or possibly entity stores. I'm not sure which yet. Am I making sense?
Okay, if you're more flexible about it, then I will still sort of set up this thing to meet with Michael or someone he wants.
Yeah, I know, but we need to know what the target is, because I think. Yeah. Okay, so Michael is saying there's also Wikidata. What was the other model that Michael mentioned?
Formula data is in a certain sense related.
Okay, so let's look at formula. Let's see, that is formula data there.
Because it's probably my bad, because I think of entities as stamp collecting a bit. It's like lots of stamps. I just need to sort them into bins.
Yeah, but there are certain things like minerals. There isn't a theory until today.
I see. Yeah.
The stamp collecting is the only choice to take care of
this
domain.
Yeah,
you are correct. The world is full of stamps.
Right.
Cities are stamps. It's all, there's a chemical.
But the model building is a bit more principled.
But my point
there's
is
stamp collection. There's quantum field theory. There's no model building.
I think we go far below quantum field theory now, but that's a different story. But the potentiometer is a stamp.
Well, okay, but then special functions are stamps too.
They are somewhat. Yeah. Yes, they are. The thing that you're not understanding, Roger, is that you think an entity is just a blob where you deliver it and there's nothing you can do with it. That is completely incorrect.
Well, I don't think that there's much you can do with it except look things up.
Yeah, but what does that mean? I mean, if I have, look, for example,
it's a great handle, okay?
No, look, if I have the entity in New York City, right, what can I compute about that? I could say geoposition of New York City. I could say local time in New York City.
Right. So we're gradually enhancing the kinds of things that interact with this.
Right. So we're computing things where the entity, it's just like, let me give you two other examples, okay? The number 75, right? What can you do with the number 75? You might say it's just a stamp, just sits out there, it's the number 75. Well, the fact is we've got 1,000 functions that probably do something interesting with the number 75. Because, as you say, it's an anchor, it's a handle to this thing, which is the number 75. So I'll give you another example. Let's try, the molecule. And by the way, this is kind of interesting because I'm now specifying that molecule.
That just gave me an idea. So let's say that we build these anchors, entities, whatever we want to call them, we could probably augment what we know from System Modeler with what we can add to from the Wolfram Alpha team by curating and adding more data.
Yeah. Yes. Yes. Yes, Roger. That's what I've been saying for like 5 years. Yes. Yes. What we would be able to do,
because,
potentiometer.
I mean, the thing is that System Modeler and system modeling is kind of, it doesn't have a story about the history of the resistor, or like who invented it and shit like that. It doesn't know, it doesn't even care. It's very utility oriented.
That's correct. But you can attach, so, this molecule, I don't know anything about, but I just want to point out, this is another kind of thing. So I might say, molecule plot 3D or something here. I might ask for some other property of this molecule, right? This is a parameterized thing. This is not as such an entity, okay? This is a molecule. I could give molecule an entity here, like, heptane or something. That's giving it an entity, but the thing you get out is a what am I trying to say? I'm just showing you this as an example of yet another kind of framework that we have, where, yes, I mean, the key point, if entities were just lookups, it wouldn't be as interesting. What makes entities really interesting is that they are things that you can compute with. Right? I could say New York City, Boston, I could say geodistance between them. Now, what is the analog of that for a potentiometer? I'm not sure, because as you say, the disembodied thing, I mean, there is a certain amount that can be done with the sort of the zero argument version of it, the disembodied potentiometer. You could ask, for example, what does it, I don't know, you could ask what units of something or other does it produce? I don't know exactly what you'd ask. What might you ask of a potentiometer on its own? Other than you could ask, I mean, if I say, gadolinium discoverer. Okay, so that is an entity property that will tell us as another entity, the discoverer of gadolinium. So what could you imagine doing?
If we think about potentiometer as such, rather than that particular one that you're looking at, of course, it's one thing you could ask which type of potentiometer it is, and in which systems it's used. If we
yeah, okay, fair enough. I mean, you could say you could ask a question like, what other things that we have is that a component?
Yeah, which we sort of that's a thing we do in the system model product today. We always show in where it's used, but yes, but we could do it more general here and perhaps fit it into, suppose there is a corresponding model for that in the PDE part of from Oliver has a potentiometer example, perhaps, who knows? Then we should be able to link to that, of course, and see details from that.
Sec on our live stream is pointing out this example. Let's take a look at this. So that's a really good example. Thank you for that example. And Michael, you should have brought up this example. The physical, maybe you did, and I wasn't paying attention.
Because it's so near to the torus example you had, that's why I thought it was covered.
But I think it's more interesting. Look at this example. This is a double pendulum. Okay, so this is incredibly close to what you're doing over here.
No, but this is a ready-made example. It's not a component.
No, okay. Don't worry so much about this components thing. I don't think that's going to be a big issue. It's just like the number 75 is a component.
Oh, I see what you're saying. The parameters for it.
Yeah, the parameterization. So I don't even know what these parameters are. What are these? Oh,
yeah,
these are
what's the description of them?
These are
the descriptions
make property association of the thing, then you see it a little bit more in context.
Right, but actually that's another kind of object, which is a quantity variable, which we didn't discuss, which is relevant to these guys, because that's probably what these should be, is quantity variable.
That's what I said earlier, it should be.
Well, I wasn't paying attention, I'm sorry. Okay, here it is. Okay, so this is, right, that's exactly what it should be. Right, do you see what this is? This is a named, this has a name, it has a visible name here, but it has, it is it is of that physical quantity type. Now, presumably over here, you know, you have units here. I doubt you've curated what physical quantity type, but you have curated what units it is. Is that correct, guys? Jan, can you say something about that?
What do you mean curated? What unit it
Okay,
has?
look here. Okay, V is a physical quantity. It's named
Yeah.
V. Okay, you have
Yeah.
a physical quantity named lowercase r here. Okay,
Yeah.
in this case, we know that V is a physical quantity. It has an entity. There is an entity which is physical quantity, right? Is that what it's called? Physical quantity. Physical quantity, electric potential. Okay. Now, it has units of volts, but there are other things with units of volts, which are other physical quantities. Do you see what I'm saying?
Yeah.
Okay. So what I'm saying is what you've got over here is curation at the level of units, but probably not curation at the level of physical quantities. Am I
Correct.
making sense?
Yeah.
Right. Although it's not that big a deal, but you know,
Yeah.
there is a generic physical quantity. Michael can speak to this because he's a big expert on all this stuff. There is presumably a generic physical quantity that goes with a given unit designation. Like
Not really. It goes
really.
only in the other direction. Like given a concrete physical quantity, it has a canonical unit, but you don't have for a unit a generic because it depends on unit systems and other things.
Okay, but so resistance per meter, we would have a notion of a physical quantity which is resistance per meter.
We would have resistivity. We would have as the canonical unit ohm per meter.
Okay. All right. Okay. So fine. So the point is this is a physical quantity, a resistivity physical quantity, which is a quantity variable with name R and some value here. And so this object, this U-line object, would be very much like this, you know, it might be called system component, you know, U-line, and then it would have an association that you know, is essentially exactly this thing here, right?
Mhm.
Does that make sense?
I mean, that just Jose and I had long discussions about this. One might even think on introducing a new symbol that connects, like you write in so many textbooks, V equals 3 volt. To unite this in one blob rather than through a generic rule.
I see. I didn't quite understand that. So you're saying, well,
you
okay,
have a physical quantity named V that has the value 3 volt.
I see what you're saying.
You're not going to like blob this together with one you had.
Mm-hmm. That makes some sense. Right, I see. So a valued, I mean,
exactly.
This is basically a valued
exactly.
quantity variable.
Yes, exactly. Yeah.
Okay, but so I want to come back over here. So I mean, the mapping between this construct and what we're currently having as physical system entities seems fairly good. Okay, now the next question, the big question is, so what do you do with this, right? Because in the system modeler world, these are, you know, things that get connected together, right?
Yeah.
And they are primarily connected, if I'm not mistaken, in graphs. Is that true?
Yes. There's a textual form as well.
What does the textual form look like?
It's the Modelica language, and you can see it if you click on that text thing up there.
Where?
Up.
There's
left.
like a paper to the left.
Like looks like a piece of paper, like a piece of text up there.
Yeah, that one.
And this one doesn't have any connections, of course, because this is just equations.
Where is the actual, okay, let's find something that has connections. Let's go to an electric motor or something.
Do an example.
Yeah.
A Chua circuit. That's
Right.
something that's a nice differential equation-y type thing.
Sure.
Okay.
That's
And
all.
there you see the part that says connect, and then it says.
Okay, so those are essentially graph edges.
Yes. And those, you
Okay,
can
so-
see the connections between ports, like the LN port is connected to the R0P port.
But presumably that there could be multiple copies, so there are multiple resistors, each with a such and such port. And so what you really need to be saying is, okay, so this
Yeah,
is
they have different names. So yes, absolutely.
Yeah.
The instances, there are different instances.
right. So the system specification would be very much like a graph, which has, nodes and edges.
And ports.
Right.
Absolutely
yeah,
need
so
ports.
if you look at the right-hand side of System Modeler, there's a component browser. And I think that to a cleaned version of that is sort of what you're looking for. So if you go now if you keep here in the most right-hand side, you see that, there, where you can expand the different, it says, okay, the C2 then consists of blah, 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 but it goes into all those details that you talked about. So it's finding the right abstraction level to what level of details are we interested to sort of drill down here, which parts of these are we interested to represent. My gut feeling tells me that it's the things that have icons to them. Those are the things that we are interested in. So for instance, the I and the V, well, they are variables. We might be interested in those anyways. But yeah, I think that view shows how it's sort of built up in a graph. And this is the one you sort of want to.
Right. But so I mean, the question would be so basically what the setup is, it's components and connections, roughly, is what you're describing here.
Yep.
Yeah.
Right. And the connections requires ports, whereas a node right now, an edge is just right now, currently, and this is something we need to fix for other purposes. Currently, an edge is just, node goes to node.
Right.
But what it really should be, and we need this for many other purposes, it should be essentially, node
dot port.
node dot port goes to node. Node dot port.
Right.
Yeah, and also here, like these ports it's important so you can't, if you have a resistor, of course, you can't connect that to a mass. So that node between them is impossible to make in them.
I'm sorry. What are you talking about?
So we know something about these edges. So there are different edges. There's a collection of different edges.
Yeah.
Or connections, just as there are a collection of different components.
But that's like unit agreement. I mean,
exactly. It's exactly that, Stephen.
Right.
It's a unit agreement. Okay. So for an electrical motor, you can't connect the torque to an electrical circuit, but the output, which is, the input, which is electrical, could come from an electrical circuit. The output, which is torque, can connect to some mechanical system.
No, I understand, but that's analogous to things. We have not had this issue too badly. I mean, this question about, unit incompatibility is something, for whatever reason, maybe Michael can comment on this. It's not a front and center in your face issue, typically. In other words, you write a formula, it has incompatible units. We say it has incompatible units, you fix it, life goes on. In other words, it's not something which holds one up a lot, I don't think.
For these big systems, it's kind of a safety thing that you can't connect. They're just icons, right? Who knows what you're connecting?
I understand. I mean, we're not trying to solve. Okay, look, the question is, the thing I'm trying to understand is, I think we're getting some sense that of roughly what the representation of the system modeler world. I mean, to me, there are several targets. Okay, one is there's a huge amount of curation that's already happened in System Modeler, which could be exposed in things like Wolfram Alpha, which is of high interest there for engineering students and professionals and so on. And it kind of leads them, if I say an overvoltage protector or something, right now, Wolfram Alpha wouldn't know anything about that, but there's probably a bunch of information that is immediately available from what's already been done in System Modeler. And exposing that is also a way to lead people into System Modeler, et cetera, et cetera, et cetera.
Right. But just so you understand, and you've heard me say this every time we meet, those examples are not encyclopedic or complete or anything like that.
I know that.
Just
I know
a
that. I
bunch
know
of
that. I mean,
instances.
I'm curious, in the world of Modelica, has somebody made a more complete, do we have the most complete collection of things that exists? Jan?
Nobody has such a collection in that sense, I would say.
Okay, but I mean, but fine. But I mean,
the libraries, all the libraries in themselves are individual collections of different things, but there's not a real.
Are there a bunch of vendors who've produced large Modelica libraries for things?
Yes, there are a bunch of vendors, and there's a bunch of open source.
Right, but I mean, component manufacturers, for example.
I think we're in the beginning stages of that.
Yeah.
Kind of what happened in the CAD industry. That vendors are starting to provide simulation models, and it's industry by industry. So like the pump industry might be behind the circuit industry.
Yeah, and many times what they want, when they have their model that developed internally, they don't want you to have access to all the details. So then they distribute that in something called a functional mockup unit, which is let's say
it's essentially a binary of some kind.
Yes, essentially a binary of it.
Okay, fine, I understand. Well, that makes sense. But okay, so look, I mean, the things that we get, we've got three parts to this whole story. We've got System Modeler itself, and there's the question of what can, Wolfram language give back to System Modeler, as in, for example, programmatically created designs, with some, I don't know what, fancy genetic algorithm, programmatically created design that is then exported to System Modeler.
I thought System Modeler is more interested in data for materials or something like that.
Well,
data for sure of different kinds.
Yeah, right. So you guys can use that.
Yes, and we can use that, and we can use that for inputs.
Is there a mechanism? If I made a Wolfram language representation of this circuit, I don't even know what that would be, and I think that's what we're discussing here. If I could make that and I run it through my genetic algorithm that uses some fancy machine learning-y thing that uses blah, 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 blah in the language, and then I want to export that to System Modeler, how would I do that? How would I even conceptually do it?
It's in the making.
Okay.
No. I mean, that works now. Just not. I mean, so that those connect. That works now. That works since we introduced it. It worked 10 years ago in the WSM link, but it works now with the system model and so on functionality.
Yeah, but I thought if you had the machine learning algorithm and wanted to use it, that was what I understand. No. Okay, got you.
Okay, so this is your version of the double pendulum. And so your version, okay, that's beautiful. We don't, in the entity, we don't, I suspect, do we have a diagram of it here? Maybe we do.
Make property association. And you see what's there.
Lots of stuff, but no diagram. Okay.
Right.
Okay, fine. But somewhere inside System Modeler, you will be able to generate equations just like this.
Yes.
Okay.
Well, not just like that, but in principle, yes.
Well, no, but what you'll have is you'll have your name variables.
Yeah. So right another thing to remember, okay, is that you could do exactly what you did here. If you manually curate the equations, you could type in the equations. What System Modeler does is to use not ODEs, but DAEs, because
I understand.
Then you have this flexibility of connecting everything to everything.
I get it. Right. Which is highly interesting. And I mean, that, right. I got it. And so here, in this case, if I were to ask for, for example, is it equation? What is it called?
Modelica equations, if I remember. I must admit, I seldom use this.
No, it's not called that. It's not. It's not.
No, it's
that.
definitely not. That.
And by the way, you need an autocomplete.
No, right. Okay,
you failed to have an autocomplete there, and you should have had an autocomplete there.
Can you take notes for that?
Yep.
There's a lot of fit and finish things that we want to do too. Okay.
Okay, but where is the equations thing here?
Which one are they?
See, wouldn't it be nice if you had linguistics where you could type in, double pendulum equations, and it would just, because I bet if I type in,
I find the initial equations, but I'm blind for the equations.
Where are they?
No, but you see, look.
I mean, it's there.
Double pendulum equations, for example. I bet I will get. That's a bit weird.
What is that?
I don't know what that is.
This gave the solution rather than the equation of motions.
But you should be able to get the equations.
Yeah, I'm sure you can. I know you can.
Yeah, I know you can, but
initial
then blind.
equations and
System equations.
Okay, all right, okay.
Yeah, system equation. Okay.
Okay. If we
How
had
could we not
autocomplete-
find that?
Okay, so fine. So then that will be your version of those equations up there, probably a little less elegant because they're not hand drawn, so to speak.
Right.
Why is it taking so long?
Well, it's doing basically a compile to derive the equations, but that shouldn't be.
They shouldn't take this time. So I don't know what.
No.
Don't know what that is.
Okay. There's some comments on a live stream, and we're going to have to wrap soon because I'm supposed to do another live stream. But okay, so 2,000 equations?
Yeah, and a lot of those are because it has an animation, and a lot of those equations has to do with animation.
Why are there equations?
And then there are a bunch of alias variables and so on that have equations and so on.
So one thing, when you do this connection bit, this is the thing you always complain about, Stephen, that you have to give names to things. Those names show up there and they get eliminated at part of the solving. This one doesn't have a lot of elimination taken care of, right? So a lot of those A equals B, basically, type equations are there, trivial equations, basically.
Yeah.
Well, okay, but I mean, okay, let's just look at a couple of these things on the live stream here. Why is there no entity queue if entities are expected to be inputs to functions?
Good question.
What was the question? One more time.
Why is there no entity queue? Why is there nothing which has a curried entity queue? That's a good point. It's a good point from Nick there. It's a good point.
So is something a valid entity?
Yeah, like this. It's a good suggestion. We should have it. I mean, it's sort of trivial, but it's sort of also useful for writing functions like that. Good suggestion. Should get added to the ILD agenda.
Okay.
Complaints that the system model IDE looks like it's from 2000.
You guys sound like me in our meetings. We're refreshing it.
Crucial says they have a new unit system prototype. That's interesting. Okay.
Who?
Just a person on a live stream here. Those are the words we eventually find out. People send in fascinating things to the function repository, or hopefully soon to the Packlet repository. What is this? That is a. What is that? That's parameter values. Oh, those things are quantity variables. So those things already are quantity variables.
Okay, yeah.
Okay. see. Yes, various people here are commenting parameter values already returns quantity variables. Oh, there's a completely out of band valid complaint. Somebody asking for 3D Voronoi. Roger.
Okay.
I'm telling you.
No,
Okay.
I know. The pitchforks are coming out, and we're actually. I haven't
Does
checked
this
today.
version
I
have
should
it? Does this? Let's just see.
I think Charles is here actually.
Charles, 3D Voronoi, is it in this version? Come on, we got to show. We got to show that
Oh,
we got to
sorry.
get the pitchforks resheathed.
Not yet, sorry.
Okay, but it is coming in this version, right?
We are working on it.
I would like to have an audible version of an eye roll. Comment that comments that it's often the case that even when there's unit incompatibility, it still makes sense. Yeah, it does for some things, but not for this modeling stuff, I think. Okay, I think I need to run off because I am supposed to do a different live stream about history of science and technology for those who are interested. I think this was a good start, guys. I'm certainly getting a sense of how these things could fit together, and I think the results will be really nice. And also, I don't think this is looking horrendously difficult, but we'll see. I also do wonder about whether could the compiler generate Modelica code, or does it not care? Could it be the case that the LLVM code generated by the compiler becomes one of those, what were you calling them, functional unit, something or other things?
FMU is primarily sort of an interface spec of things that you need to respond to fit into a simulation system.
Okay.
And so, for instance, I'm just going to describe scenarios for which I think that the compiler can know something about, and it would be probably pretty useful. So when you build a big new system, let's say you build a new jetliner, you don't build all components in one go. So you want to mix both hardware and software. And so the question is, how do you wire them up? But not only that, you might have software components from different vendors or different sort of companies.
Yeah, I get it.
That needs to integrate. So how do they talk to each other? And that's kind of what the FMUs deal with.
Right. One thing, by the way, we haven't addressed, and I really need to go, but is the linguistics of, because one of the things that's pretty nice here is that, to get this double pendulum, I can use, that's pretty obvious name, and I could use it. But, I don't think it would be, to get for your components, to get linguistics for your components seems like a very finite project.
For the components, yeah. Components.
There's thousands of them, but it's still.
Yeah, it's only maybe I think somewhere between 5,000 and 7,000. I don't know exactly.
Right, fine. That's what we do. There are however many 40,000 public companies in the world. That's kind of par for the course, easy linguistics.
The examples, the thing that so there is sort of only like coffee. There's one coffee molecule.
Yeah.
Right. There is infinitely many electrical motors.
I understand.
Okay.
That's the thing we have to address. And by the way, there are many things which have one name, but they're one generic name. Think about foods. Michael is the big expert. A hamburger.
Right.
There's a generic hamburger, and we have a way to handle that in the case of food data.
So maybe we can do something.
I would think so.
Lines.
I mean, just Michael, do you want to comment on?
So could we have a generic car? There are many cars in the world.
That's a little bit different in the example. Like for the food, we have a generic hamburger, but this is a little bit, a hamburger is more or less all the same as I say, all the hamburgers that we reasonably name a hamburger are more or less the same. Maybe they have at most a variation a factor 2. But if we have a micromotor and we have one from a gigantic ship, and we have 5 orders of magnitude difference, then some of the techniques we use right now, of course, will not apply. Makes no sense to average or take means or something
Right.
like that.
How generic? I mean, do you guys have a car? Just to give you an example.
No.
There is no car.
But we have, for instance, say we have a 1990 Honda Accord, where we average over the 4 6-cylinder model, the colors, all kinds of trims. Like we average at a level where the variations are, say, within 50%, not within 3 orders of magnitude.
We also had a project where we get the generic refrigerator, so we can do estimates of things.
Yeah.
But anyway, I need to go. But this was a good start, to be continued, and look forward to that.
Okay.
Bye for now.